Hello everyone, these are your 2.9 notes, operations with complex numbers. So today what we're going to look at is how can we add and subtract and multiply when we have i's in our expressions. So that's going to require some knowledge from before, and a reminder that I is equal to the square root of -1, and therefore I squared is going to be equal to, well, if I take the radical -1 and square it, that would cause the radical and the squared to cancel out, and that would leave just behind -1. And that's going to become important, especially when we're multiplying, because then we can simplify even further. So in this lesson, we're going to need to review radicals with negatives inside. Remember, we can break them down and then just express it with an I to remind ourselves that in our calculators, they can't compute negative radicals. So if we want to keep working with these numbers, we just put an I instead and treat it as if it were like a variable. So in number 1, the square root of -49 is the same thing as just the square root of 49 with an I afterwards. So square root of 49 is 7, so 7I. Number 2, we have the square root of -13. 13 does not break down, nor is it a perfect square, so I'm just going to leave it as a radical 13. However, I need to express that it was negative originally, so I'm going to put an I in the front. So I radical 13. Number 3, we have radical 20. 20 is not a perfect square, however, I can break it down, so I'm going to do that off to the side. 20 can break down in multiple ways. One of those ways is 4 and 5. 4 breaking down into 2 and 2. So 2 radical 5, however, we need an I. So remember the order for these is 2, it's the whole number, then I, then your radical 5. For problems like 4 through 6, you're going to do your backwards PEMDAS. This is just the square root method. In number 4, x is already almost by itself, and all you have to do is take the square root of both sides. So then for this answer, the square root of 100 is equal to 10. However, since it's an equation, I need a plus or minus symbol. And also, since it was originally -100, I'll need 10i. For number 5, similar idea, just take the square root. However, 45 can break down, and it's not a perfect square, so we break it down into, one option is 9 and 5. 9 can break down into 3 and 3. So 3 and 5. So x equals plus or minus the pair, which is 3. It was originally negative, so I, then radical 5. In number 6, I'm going to go ahead and first subtract 8 from both sides so that x can be by itself. So we have x squared equals -28. Then I'm going to take the square root of both sides. Oops. Then 28, we can break that down into 4 and 7. 4 breaks down into 2 and 2, so 2 radical 7. However, it was negative, so I need an I as well. So x equals plus or minus 2i radical 7. So the next thing you're going to need to know for this lesson is how to multiply binomials. Now remember, when you're multiplying binomials, everything needs to multiply to each other. So another way to remind yourself of, like, did I do it all, is foiling. So FOIL. It actually stands for first, outer, inner, last. But really what you're doing is just distributing, and then the FOIL helps you make sure you distribute it properly. So for FOIL, you go first to first. So number 7, x times 2x is 2x squared. Outside, so outsides. X to -3 is -3x. Your inners, so 6 times 2x is plus 12x. And then 6 to -3 is -18. So from here, you combine any like terms that you have, which are your two inner terms. So negative 3 plus 12 is negative 9. So 2x squared, positive 9, plus 9x minus 18. And that's going to be your answer. For number 8, we're just going to practice it again. We have 3x times 5x, which is 15x squared. 3x times negative 10, which is negative 30x. Negative 8 times 5, which is negative 40x. Negative 8 times negative 10, positive 80. Again, you're going to combine your like terms, and if you follow the FOIL method of first, outer, inner, last, you're always going to have those inner terms be the ones that you need to add together. So we have 15x squared minus 70x plus 80. All right, on to the back side. So here's what's going to be new for today. We're going to be adding, subtracting, and multiplying complex binomials. So whenever we do combinations, let's start with adding and subtracting. You're just finding your like terms, and you're going to act as if it were like an x value. So in letter A, our like terms are 8 and 12. So 8 plus 12 is 20. Then I would go ahead and do my other terms, which are I values, and add those together. So 4 plus 8 is 12. So I get the final answer of 20 plus 12i. Same thing for letter B. However, in letter B, we're subtracting. So we have to just be careful that when we subtract, you literally have to make sure you're subtracting those values. So 6 minus 7 is negative 1. And negative 2 minus 4i is negative 6i. Sometimes it's helpful to just rewrite the problem. So 6 minus 2i as if you were distributing that negative. So minus 7 minus 4i. Sometimes that's helpful. Other times you might want to just look at it how it's written. Now do make sure that when you're combining your like terms, you put it in the proper order. And the proper order for complex numbers is that the number without the I comes first, and then you add on the I's afterwards. So let's go ahead and look at number 9. Number 9, we're going to add. So all we're going to do is do 5 plus 7, which is 12. And then go ahead and do negative 2 plus 44, which is 42i. Move that down. Here we go. For number 10, I personally am someone who likes to rewrite it and then combine. So I have negative 10 plus 22i minus 4 minus 2i plus 2i. Goodness. So go ahead and combine like terms. So you have your values without the I, so negative 14. And then you have your values with the I, which is positive 24. Go ahead and try the next two on your own. So go ahead and add together the negative 2 and the 3. You get positive 1. 4i minus 11i, negative 7i. For number 12, again, you are welcome to rewrite it or just think of it as subtraction. But we have 10 plus 12i minus 14 plus 2i. So go ahead and combine. 10 and negative 14 make negative 4. 12i plus 2i, 14i. So that's adding and subtracting. So the last idea we have today is multiplying. So for multiplying, you have options. You can use FOIL like we did earlier, Or you can use the box method if that's something you learned in the past. I personally am someone who uses FOIL, so I'm going to be going through that today. But if you use the box method, that's more than okay, and you can go ahead and use that instead. So let's go ahead and look at what we have to do when we FOIL when there are i's in our answer. So we're going to still do everything the same, first, outer, inner, last. However, you're going to notice that there are moments where we have i's in our answer. So if we look at the first letter C, we go first, which is 6. Outer. 2 times -2 is -4, but then there's still an I. Just like when I had x's, I'm just going to put the I after that. 3i times 3 is 9. 3i times -2i is -6i squared. Now this right here is where it's different from x's, because I squared actually has a value, as we saw on the previous page. We said that I squared is equal to -1. So what I have to do is simplify that and say that this is actually equal to -1. But 6 times -1, or sorry, -6 times -1 is +6, which is why in the next line it turns into a +6. From there, you simplify just like you did in the add and subtract, so combine anything together that's alike. So we have now 6 plus 6, which is 12. And then we have -4i plus 9i, which is +5i. Let's look at one more example before we try it ourselves. Now this over here is using the box method. It's the same idea, you just have to draw it out like a box. And you put your terms into the different categories. The process is still the same, where you have to multiply your boxes together. So 2 times 3 is 6. 2 times -2i is -4i. 3 times 3i is 9i. And then we get 3i times 2i, and that gives you -6i squared. But again, just like you did in the foiling, you still have to remember to switch that out with a -6 times a -1 to get you +6. And then you simplify from there. So no matter what method you do, you're still going to get the same answer, whether you FOIL or whether you use the box method. Really, it's your choice. So let's go ahead and look at number 13. I personally am going to FOIL, but if you would like to use the box method, go ahead and draw your boxes alongside. So first to first, 5 times 20 is 100. 20 times -3i is -60i. -3 to 5 is -15i. And then -3 times -3i times -3i is +9i squared. However, we just said, hey, we can't have i squares because, again, that i squared is equal to -1. So I'm going to just really quickly, I'll just say 9 times -1 is equal to -9. So we have 100 minus 60i minus 15i minus 9. Then my last step is to combine any like terms together. So we have 100 minus 9, which is 91. -60i minus 15i is -75i. And that is your final answer. Let's go ahead and do number 14. It's the same process. So first to first, 7 to 3 is 21. 7 to 4i, 28i. -i to 3 minus 3i. -i to 4i is -4i I squared. But again, that I squared is special. And I have a -4 originally, so -4 times -1 is +4. And once you get the hang of it, you'll realize all you have to do is switch the sign for your next step. So 21 plus 28i minus 3i plus 4. Combine any like terms. 21 plus 4 is 25. 28i minus 3i plus 25i. Go ahead and try pausing the video and doing the last two on your own. When you're done, go ahead and press play and see if you got the right answers. So let's go ahead and show you how to get the right answers. 5 times 4 is 20. 5 times 3i is -15i. -6i times 4 is -24i. -6 times, or -6i times -3i, positive 18i squared. Change the I squared, so it's 18 times -1, it's -18. So 20 minus 15i minus 24i minus 18, combining like terms. 20 minus 18 is 2. -15 minus 24, -39i. One last one. 3 times 3 is 9. 3 times I is 3i. 5i times 3 is 15i. 5i times I is 5i squared. Change your I squared, so 5 times -1 is -5. 9 plus 3i plus 15i minus 5. Combine your like terms. 9 minus 5 is +4. 3i plus 15i is 18i. And that is it for today's lesson.